Hi guys, today we are going to continue talking about multiplications of polynomials, but today we are going to analyze some special methods to solve some special exercises. Sometimes they are useful to multiply some polynomials, and I say sometimes because must be we have to check some conditions, special conditions. Okay, then let's start with the first one is FOIL. And to use FOIL, let me provide example. This example, x plus 3 times x plus 5. Then what is the mandatory condition to use FOIL? Must be a multiplication between two binomials. That's all. Then, to multiply two binomials, we can select one binomial and multiply each term of that binomial by every term of the other. To remember this method of multiplying, we use the initials FOIL, F-O-I-L. Then F is because we have to start multiplying the first term in each binomial, in each parenthesis. Then x times x, of course, is x squared. O, because we have to multiply now the outside terms. Outside terms are x and 5. Then x times 5 is, of course, positive 5x. I is because we have to multiply the inside terms. The inside terms in this case is 3 and x. Then 3 times x, of course, is positive 3x. And L because we have to multiply now the last terms. The last term in the first parenthesis is 3 and the last term in the second parenthesis is 5. Then 3 times 5, of course, is positive 15. Now, as usual, we have to collect the like terms if it's possible. In this case, of course, 5x and 3x are like terms. They are the only ones. Then the final answer is going to be x squared plus 8x plus 15. Okay, now let's analyze the second situation, the second case, the second method. Product of the sum and the difference of two terms. This is the example that we have to solve, that we are going to use to explain this method. X plus 6 times x minus 6. Hey, be focused in the title of the method. Product of the sum and the difference of two terms. That means that the first mandatory condition is because it's multiplication between two binomials. Two binomials, first mandatory condition. Second, not any binomial, like FOIL. In this case, is exactly the same binomial, but in one parenthesis is an addition and in the other one is a difference. Doesn't matter which one is first. Can be the first one an addition and the second one a difference, or in the opposite way, the first one a difference and the second one an addition. Doesn't matter. Okay, but be careful with this. Then it must be exactly the same binomial and each term of the binomial exactly in the same position. Then as we can see here, x is the first term in both parentheses and 6 is the second term in both parentheses. That's mandatory condition. When this happens, then we can use this method. And this method is really simple. Then what is the method? The method says that we have to the first term that is the same in both equations, the first term square. Okay, the first term square. And now minus is always minus the second term square. That's it. That's what the method said. If these conditions apply, then the first term square minus the second term square. Of course, if we can solve any operation, we have to do it. X squared, of course, is going to be x squared, but 6 squared, we can solve that operation. Then the final answer is going to be x squared. Of course, there is nothing that we can do with x squared, minus, of course, 6 squared is 36. Then this is the final answer. X squared minus 36. Let's analyze this second example. The second example is a little bit more complicated. Okay, then be focused. Then one more time, conditions. Multiplication between two binomials. Yes, there are two binomials, but the position of the binomials or the terms of the binomial must be exactly the same. In one is an addition, in the other one is a subtraction. Okay, and the terms must be exactly in the same position. The first one must be the first one in both parentheses and the second one the same in both parentheses. In this case, it's exactly what happened. 3x to the fourth is first in both parentheses and 4 is second in the second in both parentheses. Then remember the strategy. The strategy is the first term, in this case 3x to the fourth square. First term square. Minus is always minus. And now the second term, that in this case is 4 square. Remember, first term square minus second term square, and solve any operation if it's possible. In this case, yeah, of course, it's possible in both of them. To solve the first one, this one over here, if you don't remember very good what can we do in this case, I recommend you check again the video, the previous video, that the name is exponent rules. In that video you can solve some questions about the process to solve the first this over here operations. Okay, but 3x to the fourth power square is 9x to the eighth power. Okay, that's the operation. Minus, of course, and 4 square, of course, is 16. That is the final answer. Okay, remember the method. Product of the sum and the difference of two terms. Okay, now let's analyze the third case. It's the square of a binomial, and this is the exercise, the example that we are going to use to solve this situation. Then, conditions for a square of a binomial must be multiplication between two binomials. Of course, it's a multiplication between two binomials, but the two binomials are exactly the same, not like the last one. In the last one was one addition and one subtraction. No, in this one is exactly the same, Then the exercise can be x plus 2 times x plus 2, or can be x plus 2 square. These two situations are no different situations. It's exactly the same situation. Okay. Then in this case, what is the strategy for a square of a binomial? It's very simple. Just let's use this expression here, the second one. Okay, and of course we can identify what is the first term and what is the second term of the binomial. X is the first and 2 is the second. Now let's start with the strategy. The strategy is the first term, in this case x square. Okay, first term square. Now be careful with this. Plus is always plus. 2 is always 2 also. Okay, 2 times the first term, that in this case is x, times the second term, that in this case is 2. Okay, and now plus, one more time, it's always plus, the second term, that in this binomial is 2, the second term square. Okay, then one more time, first term square plus 2 times first term times second term plus second term square. Okay, now operations. X squared is not possible, must be in the same position, but the other ones we can operate. Then 2 times x times 2, of course, is 4x, and at the end plus x squared plus 2 squared is, of course, is plus 4, because 2 squared is 4. Okay, that's all. Let's analyze another example. In this case, it's x minus 2 squared. Okay, remember that can appear in this way, or can be x minus 2 times x minus 2. It's exactly the same situation, the square of a binomial. Okay, then let's use this expression, x minus 2 squared. Remember the technique. In this case, there is just one difference with the previous example. In this case, it's a subtraction. The binomial is a subtraction. In the first one is an addition. There's just a little change. But let's start with the same strategy. The first term square. That's it. In this case, is minus. It's going to be always minus, because in this case, the binomial is a subtraction. It's in a difference. Okay? Then it's minus. Minus what? Exactly the same. Minus 2 is always 2 times the first one, the first term, times the second one, the second term. And plus is always plus the second term square. Okay? Now, one more time, operations, if it's possible, x squared is going to be x squared. Negative 2 times x times 2, of course, is going to be negative 4x, and at the end 2 squared, of course, is going to be 4. Now that's the answer. But let's analyze another example a little bit more complicated, and that is 5x cubed plus 2x squared. Then remember the strategy. The first term square. First term in this case is 5x cubed square. Plus, remember that when the binomial is in an addition, this is always plus. Then plus 2, because it's always 2, times first term times the second term. Plus is always plus. Okay, let me write it. Plus the second term square. Then the second term is 2x and is, according to the strategy, is square. And now, exactly the same, solve the operation that is possible to solve. Then the first one is possible, of course. If you don't remember, please check the video exponent rules. But in this case, it's going to be 25x to the 6th power. And now let's continue. 2 times 5 times 2. 2 times 5 is 10 times 2 is 20. Then is 20x to the 4th, because x cubed times x is x to the 4th. And now plus at the end, 2x squared is going to be 4x squared. Okay, and that's the final answer. Okay guys, that's all. Thank you so much.